Hello and welcome. This is part 1 of the two-part lesson on the Describe Geometry task of the Ansys Fluent Meshing Watertight Geometry workflow. Once the surface mesh is generated, the Describe Geometry task is used to define the computational model by specifying the type of imported geometry, executing necessary subtasks, and by creating regions that are required for generating the volume mesh. In this part 1 lesson, we will specifically discuss the working details of various inputs required in the Describe Geometry task. Then, we will learn how to create capping surfaces for fluid region extraction, followed by creating regions using the Create Regions task. Sounds interesting, right? Let's get started. Launch Ansys Fluent in meshing mode. Go to File, Read and select Mesh and then pick the provided mesh file. Once Ansys Fluent finishes reading the file, you will notice that the Watertight geometry workflow has been automatically set up and all the steps till the generate the surface mesh have already been successfully completed. The geometry we have here is that of an automotive exhaust manifold with 4 inlets and 1 annular outlet. Let us now go to the first incomplete task, which is the Describe Geometry task. Under the geometry type, there are 3 options that describe the type of geometry imported into the workflow, that is, only solid, only fluid with no voids, or both fluid and solid regions and/or voids. We will select only solid regions for our case. When we select the geometry type as only solid regions or both fluid and solid regions, we get an additional option to cap openings and extract fluid regions here. This is not available when we select geometry type as only fluid because of the obvious reason that in that case fluid extraction is not required. Here, since the geometry contains only the solid domain, we are required to extract the fluid region. For will you cap openings and extract fluid regions, we will select yes to extract the fluid region. Note that after selecting yes, the enclose fluid regions task gets added to the workflow, which we will discuss a little later. The third user input is change all fluid boundary types from wall to internal. In the models that have multiple connected fluid regions, fluid boundary refers to the interface shared by 2 fluid regions. This option is used to check whether or not we want Fluent to convert all fluid boundary types from wall to internal. By default, Ansys Fluent meshing treats a fluid boundary as wall. If the option is set to no, then there will be no flow allowed across the fluid regions. However, if the model physics is such that fluid is supposed to flow across the regions, select yes to convert the boundaries to internal. Please note, named selections that include the word wall are excluded from this conversion. Further caution needs to be taken if named selections are necessary to be assigned at these interfaces. Please refer to the user guide for more details. The next user input is, do you want to apply shared topology? We will discuss this option in detail in part 2 of this two-part lesson. For now, as the shared topology has been applied at the CAD creation phase, we will select it as no. Note that if you import a multi-object geometry where shared topology has not been applied at CAD level, then we get an additional user input saying non-conformal mesh between objects, using which we can select whether we want a non-conformal mesh or not. Non-conformal meshes are those meshes in which mesh node locations at the interface between 2 cell zones are not identical. These are used in simulations involving moving components such as compressors, turbines, gearboxes, etc. One thing to note is that if do you want to apply shared topology is set to yes, then non-conformal mesh between objects will be no and vice versa automatically. The final user input deals with the multi-zone meshing. There may be cases when we would like to have a pure hexagonal mesh for complicated geometries. In such a case, we might have to manually deconstruct or slice the geometries into separate bodies before meshing at the CAD level. However, if Enable Multi-Zone Meshing option is set to yes, then we can create a purely hexagonal mesh throughout all regions of a geometry while automatically deconstructing the geometry into separate bodies. Here, for this demo, we will select No and click Describe Geometry. The workflow now moves to the Enclose Fluid Regions task. The main purpose of this task is to create capping surfaces to cover or close any openings in the geometry and define an internal fluid region. The solid CAD model already contains the wall surfaces. We need to define the inlet and the outlet surfaces. The zone type setting can then be used to specify the type of boundary condition that will be applied on the capped surfaces. Let's first start with the inlets for our case. We will be using the velocity inlet boundary condition for these surfaces. The name field is auto-populated depending on the chosen zone type. We can either keep this default or change it as needed. We will use the default name for this demo. There are two types of cap types that the user can choose from: single surface or annular two surface. If the opening is annular or ring-like, the annular option needs to be used. For all other openings, we can use the single surface type. We will first use the single surface cap type and we'll look at three different ways to create cap surfaces at the inlet plane. To create a cap, the surface that surrounds the opening needs to be selected. Ensure that Select By is set to Label and from the list select In1_face. The corresponding surface is highlighted in the graphics window. This surface surrounds one of the inlet openings. As soon as you hit Create Cap, a new surface is created which covers this opening. There is no requirement for the surrounding surface to be just a single entity. For example, the second inlet is surrounded by two surfaces. To create a cap for this inlet, set Select By to Zone, select both surfaces, that is In2A_face and In2B_face by picking them from the list or by graphically selecting them and click on Create Cap. A capping surface is created to cover this opening. It is necessary to set Select By to Zone before selecting the surfaces from the list, since both surfaces have distinct labels. If they are instead grouped into a single label at the CAD creation phase, Select By can be set to Label and the appropriate label can be selected. It is also possible to create a single capping surface that covers physically distinct openings as long as they are on the same plane. For example, to create caps for the remaining two inlets, select both In3_face and In4_face and hit Create Cap. This will create a single capping surface that covers both the selected openings. In this case, it does not matter if the two surfaces are grouped into a single label or not, since they are physically distinct surfaces. Let us now shift our focus to the outlet plane. The opening resembles that of a ring or annulus. To cap such openings, we need to use the annular two-surface cap type. Select this option in the Enclose Fluid Regions task. Since this is an outlet, we will set the zone type to Pressure Outlet and retain the default name. To create an annular cap, select two surfaces that surround the opening, that is, the circular inner surface and the rectangular outer surface from the graphics window. Make sure that the Select By is set to Zone. In addition to selecting these surfaces from the graphics window, one can set the Select to Label and then select the label that contains both the surfaces. it is mandatory that both the surfaces for an annular cap type are grouped into a single label. In our case, the label out_faces contains both the surfaces. Hit Create Cap. This will create the annular cap at the outlet plane. Now that we have the fluid domain boundary defined, we need to inform Fluent to extract the fluid region, and this happens in the Create Regions task. This task is only available when the geometry consists of solid regions only, or the geometry consists of fluid and solid regions and/or voids option is selected under geometry type. If the geometry consists of fluid regions only is selected, that indicates that only fluid regions are present in the domain and hence no separate extraction is required. The only input in this task is the estimated number of fluid regions. This value in fact is automatically calculated and set by Ansys Fluent. By default, Ansys Fluent assumes that all bodies are solid regions and all voids are dead regions. The conversion to a fluid region happens in many ways. Please refer to the user guide for more details. Click on Create Regions to let Ansys Fluent extract the fluid regions. Any extracted fluid regions are immediately displayed in the graphics window. If more fluid regions are detected than the estimated number, a warning is printed to the console window for the user to investigate. This brings us to the end of this part 1 lesson. Let's summarize what we learned in this lesson. We understood various inputs required in the describe geometry task to properly define the model. Then, we learned the working details of the enclose fluid regions task and understood how to create capping surfaces for fluid region extraction. Finally, we learned about the create regions task of the Watertight geometry workflow. With that, let's wrap up this lesson.